Hello everyone. Hello everyone. Good morning. I'm Yiqun from Imperial College. So here I'm giving a presentation. I've been invited by the Breathe London community. This would be a first talk about the series presentations from the community, and I'm today my talk is mainly targeted on air pollution and the runners, especially related to the exercise or sports. So I'd like to give a little introduction about myself. So this is a picture of me. Uh, that was me in London Marathon. But before that, I'd like to say that I'm a researcher in Imperial College in the environmental research group. So my research interest is basically into two topics. First one is related to the environmental health. I got a background with medical, so quite a lot of my work is trying to look into what's the health impact to human health, especially related to air pollution. And the second bit is more specific, is just trying to look into the individual or personal exposure to air pollution. That meaning that I wanted to exactly look into the pollutions or air qualities around yourself rather than in general in the ambient. I have been working in this area for a while, but I have never really looked into the topic, especially with the runners. But me myself, I'm kind of like running quite regularly. I have attended several races, marathons, especially. For example, this one in last year's London Marathon. I was quite happy that after 5 years drawing, that I finally get the slot and get into the race. That was amazing. That's one of the best marathon I have attended. So quite enjoying that. Um, so you can see that I have an interest in this in sports in running, but and also I do quite a lot of research in environment, but I never quite really link into that. I'll explain later why it's happened like this. But after I have been given this topic from the community, I said, okay, that's interesting. I probably will look into the field and to see what's going on in this field, and that might help myself. And also, I like to see if this information I can help or contribute to the community as well. So when I first get into this topic, the first thing first into my mind is this book. It's written by a professional Japanese writer, Murakami. So this book is called "What I Talk About When I Talk About Running." So this is quite an interesting book. I strongly suggest it. I probably assume that most of the runners have read it already. So the book talk about the kind of like some thoughts about running and also writing, especially for the long novels. So there are quite some similarities in between these two. And also for Murakami, so he's an amateur runner, but he has managed to made into sub 3 hours, 3.5 hours in the marathon race, which is quite impressive as I would see as an amateur runner. Um, so I think that takes quite a lot of running. But back to the topic of the book, I think that also related to the air pollution. I think this, I'd like to ask the same similar question, that is air pollution a problem for runners, right? So intuitively, I think yes, of course, because when we run, we just breathe in and breathe out really deeply, and then definitely we wanted to run in an environment with a good air quality, right? And then the matters of health, and also what more concern to runners is, would it affect our running performance, right? So this is the two questions that's directly come into my mind. I think they're relevant. But I also put some comments or potential questions here, as maybe there's you as a runner, you probably concern more about air quality. And for example, you wanted to avoid the traffic use, you wanted to avoid the pollutions while you commute to the work, you want to reduce that. Maybe that's one of the reason. Or if you have some other thoughts on this topic, just put your thoughts in the comments so that I probably can know what you want to understand about air quality and running, and what you're concerned about. I probably will do some research to see how I can contribute to your work, to your running. Um, Um, so when I talk about getting into this topic, right? So most of my work related to air quality and health. So that a key question is about who are the population that is we should target it on, who are the most at the highest risk. So there are a lot of research talking about that, and they're about elderly people, they're about children, they're about pregnant women, they're about those with diseases like a respiratory disease, asthma, or cardiovascular disease. So these populations are vulnerable to air pollution. But well, would-be runners also a targeted population? When we think about runners, you probably will have the general impression as the pictures on the right, right? They looks very fit, their health. Um, so probably air pollution is not relevant to them. They don't mind about that. Air pollution is not targeted population. They're not air pollution targeted population. So I wanted to ask you that do you agree with this topic or argument? Because when I think about that as a runner myself, I think maybe yes, but also maybe no. I'm just kind of hesitate because think about that in another way that these runners they are fit actually, of course, but they're also quite keen or enthusiastic in their health, in their performance. They care a lot. For example, if there's a new type of shoe technology just uh, 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 get out in this new year, they will just look into the perimeters, even just like a tiny bit of increase in their performance, they will happy to try for it. So I will assume that's the same for air quality. If they can care about air quality a little bit more, and then they will improve a little bit of their running performance, making their finishing time like a several seconds um, better, they will be happy to try for that or care about that, right? So I would say that definitely a targeted population we should look into. And before I get into this topic, I'd like to give you some of the background of air pollution, some numbers. Okay. So this one is from a WHO's report. So from the report, we know that around the world, 9 out of 10 people are right now breathing the polluted air, which is exceeding the WHO guidelines. That's quite huge, whereas a terrible number. And they have a list of risk factors globally. So in general, air pollution is counted as the fifth global risk factors. That means that based on the calculation, it will attribute it to 7 million premature deaths annually every year around the whole world. That's a huge number and a huge public burden. And also when we talk about air pollutants, we can look that into different dimensions. We can see it in different pollution species. For example, particulate matter, which is a small particles. That's one of the key players in the air pollutant, how to say, group. And also, if you look more into detail, there's different chemical as well. For example, the black carbon as one part of kind of like a chemical species of particles. They're mostly freshly emitted from traffic. And also there's some gases pollutant as well, nitrogen dioxide, ozone as well. There, each of these pollutants, you will have a huge number of reference looking the health effect behind these particles. And also we wanted to trace back to the pollution sources, right? So as it depends on where you live, like in the city area, you probably will assume that most of the pollution sources are either from traffic or from industry. This is mainly from the outdoor settings, but if you look into indoors, there's a kind of like another setting we probably largely ignored from household, from cooking, from fuels we use daily. So we have different ways to look into the sources as well. So here is a guideline from WHO. You can see on the left-hand side, they listed some targeted or the main pollutant we should look at, including PM of different sizes. The PM 2.5, one of the main one is the particle matter with diameters less than 2.5 microns. PM 10, less than 10 microns, ozone, nitrogen dioxide, etc. But I wanted to highlight here is about the guideline on the 24 hours guideline. For example, these two last columns shows the change or update of the WHO guideline from 2005 and 2021. So recall that last slides that we see 7 million premature death is actually based on a calculation from 2016, and that's using the level of 2005. That's quite old. So at that time, 24 hours guideline is 24 microgram per cubic meter for PM 2.5. We calculate as 7 million. And right now they have updated that 2 years ago. They updated and decreased that the guideline into 15. Why? Because they see that even in 25 microgram, this older guidelines, you can still see some of the health impact. So this is not clean enough. So the threshold is even lower. So they just improve or upgraded the levels to a more cleaner level. So the whole knowledge is kind of like we probably experience or we probably have more health burden than we expected from the last knowledge. And also regarding to the health effect, so let's look at the pyramids, which this is probably a graph which is very intuitive. So the data we just talked about, you can see on this pyramids is actually just a tip of iceberg, right? So that's only the end of the health outcomes. Actually, if you look at the health effect, it's a whole spectrum. So before you get into this end, you probably will already experience some of the diseases. It's either respiratory or cardiovascular. You probably need to go to hospital for a doctor. And then even before that, you probably will experience some of the symptoms, right? You're coughing, you probably have sneeze, nose, runny nose, etc. Some respiratory symptoms. So there are even more people experience that. And even beyond that or before that, you probably will have some of the biomarkers or biological changes inside your body caused by the air pollution, which is just kind of like not easy to realize. So this whole pyramid is just a sum up for a larger population than what we have expected from the death. And beyond that, we can also look the health effect into different ways. Like it's either could be short-term effects that's more relevant to runners. After you go for running, you probably will experience the short attack from the pollution, and it could also be related to some long-term effect that cause chronic diseases. So in terms of the diseases or different systems, definitely we know that it related to respiratory or cardiovascular disease that probably intuitively we know. There are also quite a lot of evidence recently showing that can be the air pollution's impact can even go beyond that, can cover into metabolic disorders like diabetes. It then can also related to some of the mental disorder. Probably, I don't know if you have covered all that, but there's a whole lot of research and the biological analysis lab works related to that. So the point is the health effect has covered different systems of the human body, so it can cause quite a lot. But all the studies I mentioned is mainly targeted on the normal population or some of the sensitive population, I said. So when we look into the topic related to runners or those who's really active in exercise, the studies are quite quite limited. So the reason I pointed out is maybe because of the impressions on the subpopulation of runners group. Maybe some of the other, but well, from my review, I see there's not much, but they're quite interesting actually. So I just put out some of the papers or studies that I felt quite useful, which might be useful for you as well, just highlighted here. So the first is actually this is just about air pollution exposure, nothing related to health, but this is quite relevant. This is two plots from two different studies. So let's look at the first one on the left. Okay, so this is studies from US. It's actually a modeling work. It's trying to look into the particulate matter count on an athletic field just right by a roadway with a lot of traffic. So on you see the 3D box. It's actually with a 50 meters times 50 meters pitch. All right. And on the y-axis is the PM concentrations. The higher means that you're looking into a high exposure of the PM. So this surface is actually a modeling of the PM concentrations close by the roadway with a change of the distance. So basically the conclusion is, as you're getting closer to the roadways, even just within the 50 meters distance, very, very, very short distance, you will experience you will see an exponentially increase of the PM concentration. Suppose you're playing or doing some exercise just very close to the side of the roadway, you probably experience like way much higher PM exposures compared to the ones just a little bit further. And that can also be related to some of the city planning, kind of like intuitive generations. Like, well, if you're trying to choosing some of the playground or athletic field for your sports, you know that there's a lot just in London as well, right? So they're quite close to highway, or there's some just like a little bit further away. So probably choose it. You will have different levels of exposure significantly. So that's kind of like a one message, very important to me after reading this message. And the second paper is actually about running. So, oh yeah, I forgot one point about this first paper. It's more like um, about the particles characteristics. So these particles is actually are very fresh, meaning that they just freshly emitted from the roadway. So what is the characteristics of the particles freshly emitted? It means that they're small. They haven't not grow up. They're still very, very small, like 50 to 100 nanometers. That means they're easier to reach into the deeper version of your respiratory system, alveolar region, and then even go further into the circulation, into the blood, so cause some problems. And then the second studies comes related to that point is when we're doing our sports, we definitely have increased the inhalation rate. So they're trying to compare the two groups, like one with a 1 hour rest compared to another one just with a 1 hour exercise to see how much particles will deposit in the deeper part of the lung, right? So you can see that this number on the y-axis just showing the model deposition particle counts. On the group with exercise, 1 hour exercise, you will see you will expect like a 5 or 6 times higher particle resolution depositions in your respiratory system. That's huge difference as well. And then these particles, whichever deposited in the lung, can cause oxidative damage into the tissue, can cause inflammations in the airways, then that can lead into the subsequent health outcomes. So that's about the exposure, about just like the air qualities we breathe in. And then when we look into the health part, so not much studies, but this is one that's very very classic, I would say, in this field. It's called Oxford Street study, exactly done in London. It's quite classic or smart study. What did they do? The research do is actually they trying to design two scenarios, clean versus dirty. The clean one is actually the dirty one is actually in the Oxford Street, which is one of the busy streets in London area. You can see these pictures maybe showing exactly the cases where the buses or the traffic congestions in this area compared to a clean scenario, which is in Hyde Park. Hyde Park is just like by 5-10 minutes walk along Oxford Street, very close by. So spatially, there's not too much difference if you look into an ambient level. However, the settings about the traffic is totally different. So there's two contrast settings, one with the high pollution, one with the low pollution. They ask a group of subjects taking 2 hours in either of in two of these sections. So they will do like a 2 hours walking in Oxford Street, and after several days clean up, like they call washout period, they will ask them to do again the second round walking in a low pollution. Okay, so each of the participants have to do a separate walking. So after this walking, they're trying to look into the health effect, especially looking into their lung function. So on the two plots below, it's actually two perimeters. They both represent the lung function. The lower means you have a bad or worse lung functions. The higher, the better. Okay. So on this plot, you will see two lines. One is represent as a low PM concentration, which is clean settings, and the lower one is a high pollution settings. And they're trying to measure the participants' lung function in several different time points, several hours after the walking session, like after 0 hours, 2 hours, 3 hours, and 24 hours. So they will see the health impact in different time windows. So the general conclusion is both of the perimeters showing the lung function, they will see that concurrent significant decrease in these two perimeters in the lung functions from those working in the high pollution exposure scenarios, right? So you will see from the first hour, you will see a clear difference compared to the baseline level. However, compared to this scenario, if you're looking into the working in the low pollution level, well, they decrease a little bit or not much. They still vary around the baseline. No statistical difference. They basically remain unchanged for those who working in the low level. So that's kind of like a very, very classic evidence to showing the results about the pollution's effects on respiratory or lung function. And the second study related to health is about running performance. I think that's most runners here just care about. Not much studies on that, especially related to the real world analysis, but there's some good attempts on the studies. This one I pick out is the first one touching on this topic. So the author actually doing just data analysis. So he put out the running data or finishing data from the 7 competitive US marathon races, the New York one, Boston, Chicago, etc. So they pull out their historical records of each year, each race, the first 3 runners finishing time by seconds. Okay. They also pull out the air pollution level by the racing day. So they're trying to, so they have a paired data set of these two perimeters. They're trying to look into if there are any relationship between these two perimeters to see. So here's the results about the table. The first conclusion is they're trying to look at different pollutants, the key pollutants we mentioned about. And I just use a red box to highlight the national air quality levels regarding to the pollutants. So the general conclusion is that on each of these race days, the air pollution concentration rarely exceed the national standards. Okay. However, when they're trying to look into the pollution level with the finishing time, what they found, one of the interesting one is they found the PM10 exposure is significantly correlated with the finishing time. With a higher PM10 exposure, they will assume that the record actually is the finishing time goes higher, meaning that it finished slower in terms of the high or a bad pollution. So they even have some of the quantitative analysis with a 10 microgram per cubic meter increase in the PM10. The performance will decrease by 1.4%. So assume that for the elite runners, that will be quite a lot for their performance. But to be noted that there's some following studies after this first one, variance settings, but the results is not that consistent. Some found there's positive correlations. Some found there's no correlations at all. But this results kind of like highlight or give us a hint that, oh, potentially that pollution can cause some problem. For example, when they look into the subcategories of the population, they found the results only occurs in women. Maybe they're more susceptible to the population pollution impact, etc. So that's related to the runner performance, right? If we even want to understand what's behind the impact on the runners, there's even less limited studies. and I just found one maybe that very relative. And this one is doing in lab or exposure chambers, meaning that they kind of like have a small chamber of setting that they can set up the pollution level in the chambers. Yeah. So they will just get some volunteers. In this study, they're just trying to recruit 16 healthy young male college students as participants, and then ask them to doing exercise in this exposure chambers, right? So what they're asking them is to do follow a pattern of cycling, cycling patterns with a 20 minutes sub maximal cycling plus a 6 minutes maximal work. So again, it's kind of like a crossover study design. They ask them to do either in a low pollution level or in a high pollution levels repeated. And here I just show two key results from the study. The first one on the left is trying to look into their work accumulations, meaning that how when they're doing this maximum exercise, how much work accumulations in terms of kilojoule they can reach into in the setting. So you can see there's a significant decrease while the participants trying to work out in the high pollution level. There's a very much very significant decrease. So that's a very good evidence. And also in terms of more detailed measurement, there the researcher was trying to measure their blood pressure, and you can see the blood pressure after this trials. So they're trying to compare that either in the low pollution day one, low pollution day two, high pollution day one, high pollution day two. So the high pollution settings is always have the post exercise. When we look at the post exercise, they always have a much higher blood pressure level. So that's kind of like give us a hint that the pollution might well their worse sports performance may partly related to the impaired blood vessel dilations or etc. So this kind of like give us an idea to look into the mechanisms. Although there's not too much studies onto the detailed biomarkers, etc. But this is kind of like a good start or basis that we wanted to understand. Okay, next question I think about on this topic is about, well, we have to do exercise because we all know that exercise is good for health. That's a basic knowledge. And we also have the knowledge about if we're exposed into air pollution level is really bad, and then they can be bad for our health. So it's contradictory, right? So should we do exercise and there are pollution settings, and how we should work in generally how we should act in that sense? So there's not still enough evidence to draw a conclusion what's the net health benefit, but in general I would say from my the reviews I have go across on this topic, I would say, well, they still, most of the researchers will still suggest doing exercise. Definitely you will experience a benefit, you will get a net health benefit afterwards. So maybe this paper I listed here is a good example to show you about the idea. So on the y-axis, it's actually, that's a relative risk of the mortality, or you can interpret it as the health impact. If it goes higher, meaning that's higher than one, that means you will experience a higher risk of health impact, right? If you're lower than one, means that you're getting benefit. And then on the x-axis, meaning that they suppose you do cycling how many minutes per day. So after they do just using the modeling to predict the results, you will find this kind of like a tick shape or L shape of the performance or net health benefit. So on this L shape, there are 2 points very important. One is called tipping point. The other one is called break-even point. The tipping point means that until you reach the tipping point, so you're doing cycling or you're doing exercise, you will keep getting increased health benefits. So this is kind of like a calculation or modeling results from PM background, and they're like 50 microgram per cubic meter, which is a little bit similar to London or UK background. So you will get an idea like after doing cycling around 1.5 hours, you will still like have like improved health benefit in this level. And then if you keep doing the exercise cycling until you reach like almost 6 hours, you probably will reach the second point, break even point, meaning that you will have no more health benefits at all because you will reach the air pollution adverse impact. And then if you go beyond that cycling, you will have more health adverse effect issues. So that's kind of like a general idea, but this is calculation based on the 50 microgram background. If you're looking into this kind of like a modeling results, you will have different settings. If you're looking into different city levels, some pollutant cities, you probably will have a different scenario or strategy for your exercise plan. So okay, that's basically the point that I'd like to share with you about the papers or research from my readings. So far, when we have this information, what should we do? Or any practical suggestions? So that's the point. I would say my thought is there are many. After the reading the papers, you will have a lot of very detailed suggestions, right? But I wanted to have maybe a little conclusion, or my interpretation is the key is awareness. How we understand about awareness is about we understand about the pollutions around us, right? If we think about air pollution, we know already the topic. You don't need me to give you that information already or those papers in very detail. You know that pollution is bad for your health, but how can that knowledge converted into your behavior, into your change? Well, you will think about that to change your exercise or training plans, right? That's the key. So the key is about awareness, to my understanding. You have to aware yourself rather than know it from papers, from government sayings, from that's important, but it's not your awareness. So how to get the awareness? That's the point. Before getting into that point, I wanted to go back to this slides. Okay, so remember that we have this scary number about 7 million premature death attributed to air pollution. How we calculate this numbers? Do we think about it? That's quite a lot, right? So actually, this number is calculated based on the fixed monitoring site or modeling in general. It's not kind of like a rather the pollutions around you. What does that mean? Like this is a map showing London, and each of the circles showing the points of the air quality monitoring site, which you can basically go to this website londonair.org. You can have a look yourself. You can play around with a little bit. You see this each of the dots or circle have a number or color within it, showing the qualities in air quality in this area, right? The greener, the better. The darker, the worse. Okay. So suppose if you wanted to say, I live in the chalk farm area, so I wanted to see what's the air quality right now around me. You probably will look around. There's not much air quality stations around me. Maybe the close one is either King's Cross or somewhere nearby. So that's not ideal, right? So you see, there's a like sparse gaps between, and then the air quality scientists, they just improve that into a second version that they use this monitoring sites. As long as there's enough, they can generate a modeling so that they can fill in the gap of the city level. So you will have a better air quality readings or predictions. And then, for example, this is a map created actually from our group ERG and Imperial. So we can see that this is a darker area. It's actually just highlight the pollution is really, really bad, and it's mainly related to some mainly traffic roads, etc. So yeah, that's better. You can maybe target it down into your area. And the modeling resolution, spatial resolution is pretty good down to 20 meters. But in general, it still have a problem is kind of like the resolution on the time is we have to have a daily resolution. It's not kind of like a real time. But imagine you're a person, you probably will traveling from you're living in the home address this time, and then you were going to the office the other time in a day. So you will move around. You have your daily activity, and your pattern is totally different. Your daily activity pattern is different. So that also matters quite a lot, right? So that meaning that we have the resources from outdoors or pollution readings from outdoors down to locations like your home address. But what really we experienced or we inhale into is actually personal level, is our personal exposure. The air is actually around us. There's still a gap. And then how to fill in the gap. And that exposure level is actually directly related to the health impact from us, right? So how we can fill in the gap in the middle is still kind of like a question mark. It's something that the whole field is trying to dealing with. One of there's several ways to solve that, but here I'd like to introduce one of the most promising way, which is using portable sensors, and also another way I'll talk about later. But this is kind of like emerging fields in this area. That's just due to the technologies just improved the recent years. And then we have so many small sensors created in the market. So previously we used the big reference instruments on the sides. That's huge one. And then right now it can downsize into some portable versions, which we can even carry on with our daily life. For example, in the middle size, the two pictures in the middle or on the left, this is the one of the sensors we developed in our team with the collaborators and then working using them for research. And then there are also some commercial ones. For example, the London Mayor is carrying the sensors, which is measuring. It's quite tiny, but measuring the black carbon on the traffic. So there's some commercial ones, and there are also some lab standard ones, I would say. So they kind of like give us a potential that we probably can use them properly to understand the pollutions around us. The only issue is it's still kind of like an emerging field. The sensors, some of them is not in a very good quality as you wanted to know exactly the quality or have a precise measurements. You probably wanted to have the lab values, but they kind of like brought up or open up for potential for the same. Why is the exposure sensors important? I wanted to highlight using this studies as an example. This is a study done in Austria. So they have given the sensors to a family, actually like a couple in just living in the same home address, right? So trying to give the sensors of black carbon sensors to measure their daily exposure levels. As you can see on this map, it's actually a time series map of 24 hours activity or exposure patterns of the men and women living together. So the men's exposure is on the black line and the women's is on the gray line. So think about that. If we're using the traditional methods, using the modeling results, okay, the couple living in the same home address, they should be assigned with the same exposure level, right? But what about their personal exposure in the real world? So this man, you see, he has experienced the high peak in first the morning hours, 7 to 8 o'clock. He probably going to work in a car driving, and also in the evening time he finished the work and also driving. So this is the main two high peaks in his daily life. And also for the women, I think she work at home, and also in the afternoon she just goes out with a little bit social work, taking bicycles. During the time she probably have passed maybe a traffic, he has experienced a really high short peak, and then later on in the evening she joined the guy, and then they just both in a car and have a similar exposure level. So that's a totally two significant different exposure patterns of the person who live together. And when you calculate their individual black carbon exposure, that can be significant difference, like by 30%. So that's a whole lot. In that sense, that's giving you a really, really good examples of how important you wanted to understand your exposure. That's what I talk about, awareness. So when we're trying to do that, me, my colleagues, and we have worked together with some colleagues in MIT um, on a project called iPass, which just actually trying to, it's not specifically related to runners, but it's more like related to the individual or personal exposure. We're trying to think of what's the best way to raise the awareness of everyone about the exposures around them. So we just have this collaboration together on this topic. One of our solution is kind of like trying to combine the sensor technologies we have right now. One is that I've shown you about the sensors we have, right? We can take them to measure the qualities around us. And also we can also have some of very convenient wearable sensors already in the market, like the watches, especially you see this runner just finish a running session and you see his trajectory on his app. So I assume most of you as a runner, you have using a lot of similar apps as well. You have your trajectory, and then they can be combined together with the monitors, the small sensors. So you can know exactly with the trajectory how much exposure you have experienced to in the day or in a runner course, in a runner session, etc. So that would be very interesting to look into. We have tried out that ideas with several pilots in our study. So this is the first one that we have been come over to MIT to visit our colleagues. We take the small sensors with us, and this is our colleague Simon in MIT. So he has kind of like a connection with the local runner group. He also a runner himself as well. So I just actually joined the group for an evening running just alongside the Charles River, really, really beautiful, and also show some of, I use the run with the monitors with me, and also trying to showing some of the runners who's interested in what I'm doing now. So so this is kind of like a pilot results about what we measure during this trial running. It's actually the whole session is last about 2-3 hours, studying from a park, and I just get the pointers out. So we're just studying from the park and then run a whole round across the Charles River and get back. So here's two plots. One is the PM 2.5, is the exposure we care about. The second one is the heart rate, because sometimes you just the changes heart rate is actually related to your breathing intensity. So I wanted to also point it out as well. So this running session is actually cut off into several sub sessions. It's more like a running like 1 kilometer. It's only 5 meters in total, 5 kilometers in total. So we're running like a 1 kilometers, and then rest a little bit. There will be some instructors taking you to do some HIIT move, and then we just keep on going for the second section and go to third, etc. So the point exactly you can see from this PM 2.5 trajectory is there's some of the high levels here in certain points. Even along the river, you will assume that's quite clean, but you will still see some of the high exposure here, and the highest can goes up to 20 microgram per cubic meter as well. And beyond the, for some of the sections we run slow, for some of the sections we run really, really push thrust. So you will see my heart rate also change in different sections, right? So that's kind of like every runner team, you will have a strategy for your plan as well. Then that matters as well. And if we look into that into the time series plot, where I just plot the PM 2.5 for the whole session, the spikes is actually where I have experienced the punctuate PM 2.5 peaks for certain time point. And also I highlighted the US guidelines here with the green one, which is the oldest one, 25 microgram per cubic meter, and the clean one, red one, 15 microgram per cubic meter. And each of them, you can see the PM exposure, PM 2.5 exposure actually exceed the levels quite a lot some of the time. There's only like a baseline is just around that air quality guideline, but most of the time it's exceeding. And when we examine the interesting peaks, we can see, well, these peaks may be relative to certain activities. For example, I did some of the diary or recording. When I do the measurement, I can sense this high peaks, especially when we run just past the park, get into the river, so we pass across the street. There's some traffic alongside. We can see a high exposure here, and when we get to here, we stop a little bit to do the HIIT. There's a really high exposure as well, and we assume that is maybe related to the suspended dust just by the ground. So you can see the running or the activities, different activities, they can cause the PM pollutions from varied pollution sources. So we will look into that if we have more information. But this is just give you a general idea how you might look into your personal exposure if you have these devices or tools. And then after that, we also have a visit back from MIT colleagues. They come over to Regent Park to London and visit us. And we also have a pilot running, and we have to do several interesting experiments. This time, we're just working together with the Tenzing. It's also a company who has a close link with the running group. So we asked them to do basically 2 experiments this time. It's also similar with the personal exposure monitors, but covering different settings. The one is trying to look into the comparisons of exposure in 2 different routes. One is in the Regent Park route, is in the park route, and the second one is trying to get a closest route on the roadside, but very close to the running route in the park, but it's on the roadside, which you will expect quite a lot of traffic. And the second one is when we finish the running from A to B point, which is quite close to Primrose Hill, and we start a second experiment, is ask the runners to do running, either go up into the hill or just running across the hill, which is on the flat terrain versus the slope terrain. This experiment is we're trying to understand whether the running intensity or a different terrain will cause the exposure difference. Okay. So here's basic results. The first experiment, park versus roadside. So you can see 2 runners starting same time, starting from A, this point, and finish at B. Okay, here, almost the same time. Finish the running, and the color scale showing the PM exposures. They can goes up to, okay, let's cover a little bit. They can goes up to like I think over the highest point of PM 2.5 is over 100 microgram per cubic. Is exactly experienced on the roadside. But in general, when we summarize the statistic here, roadside compared to the park run, you will see a clear difference. Well, although each of them have experienced like extreme pollutions, but in general, on the average, you will see roadside exposures is way much higher than, significantly higher than the park run. Okay. Okay, that's the point. And okay, I probably forget the time series plot, but I just like to mention there's a high extreme point from the roadside running, especially I think it occurs somewhere here, where we're just running past a smoker on the roadside. So that's just instantly high peak. If you look at the time series, it's very clear. Quickly goes up and quickly down. So that can capture your running exposure pollution sources as well. And the second experiment is running on the Primus Hill. So we see these 2 different settings, and also one is on the right hand side, we show the PM 2.5 exposure, and the left is heart rate. So both of the runners starting on this lower bit, point A, and running to point B. And the first one, just a first group is just go up to the hill and then downhill, and the second one just go around on the flat hill. So what we see here is the PM 2.5 exposure is a little bit higher on the group just running up to the hill. But I just wanted to point out that if you look exactly at the concentration level, it's actually not too much difference. It's only the maximum is only 50 compared to the previous one is over 100 or 200 microgram per cubic meter. So in general, these two scenarios, the PM 2.5 exposure is not too much difference. Maybe the running uphill caused some of the suspended dust, so that's raised a little bit exposure level, but not much difference. But what I wanted to highlight here, which we haven't expected, is the heart rate. So what would you think about the heart rate change if you're running if you do the hill running, right? Well, before the study or before the pilot run, we think that, okay, definitely you will experience a heart rate increase really high while you're running uphill. But the reality is the heart rate is actually get to the maximum after the runner going to almost the finishing part, which is almost downhill to the end. So the reason for that is because this run is not very long. It's only like 4 minutes maximum running. So while it's running uphill, the body is still getting a cumulus to it, and then the heart rate goes up, but not very much until the runner has going to the top to the maximum, and then going downhill, the heart rate catch up finally, and then goes up really high at this point. Well, you see those who running on the side part, the runner doesn't experience the same. But what kind of like a key message this give us? Imagine that you're running for a session that's doing an intensive running session today. Then you will finish up the running with a really high heart rate, and then you probably not rest enough, and then you just go back home or go to work, etc. To jump into the bus or jump into even the subway, right? So in that time, your heart rate is still not lowering down. It's still in a really high level. And then you're breathing a lot. And then you're getting into a quite bad air quality environment. So that's kind of like a key issue, probably not much study touch on, or we are just a lack of awareness about. So in that sense, heart rate, PM 2.5, together, you have a combination of this different parameters will give you a better knowledge or information to aware how much personal exposure you are experienced to. And what we wanted to even go beyond that is kind of like, right, the sensors is one of the tool in the toolbox you can play around with, but I know that some of the audience, they may ask around that, okay, that sensors probably it's not easy to access. It quite cost maybe expensive for some of the reliable sensors, or not very easy to use, etc. So maybe there's some other way that we're thinking about. We're trying to build up some modeling, trying to linking the sensors with the wearable watches, with the phones, with the models, that you can have an app that you can easily visualize the exposures based on some of the data we created. And then you can have the trajectory, have your running courses every day, like what you did already. And then after the running, you probably can read from the app about your exposure daily or on the activities. That will be more convenient for everyone to use, and then probably another solution to this problem. So that's kind of like the thing we're already working on. We already have some basis, but hopefully we can have more to talk about on that. So that's kind of like a very interesting directions we're going into. So back into the last several slides. So practical suggestions. Again, awareness. That's a key important issue. That's about the whole idea. If you know the pollution yourself, you don't need any suggestions from researchers, from government. You know exactly what you want to do. You know which of the day or the point or the activities that relative to the high exposures, just tailor to your daily life, right? So you will know how to change. So, but in general, okay, maybe related to what we have gone through or learned right now is some of the practical suggestions would be think about the pollution sources, what might be related to you, the locations, like we said, the pitch is close to the road, or even the time of the day. Some of them even in the same pitch or same area, same playground you're training every day. If you're training in the evening hours or in the noon, that might be different. And also it depends on the time patterns of different pollutants. We probably can go deeper into this discussion, but um, that's kind of like an issue that you think you might take into considerations about the locations and the time of the day you wanted to choose for your plan. And also taking care of the ventilation rate that probably a lot of people or runners would ignore, trying to rest until your breath level really calm down into the normal level, and then before you getting back into any traffic back home or to the work. And also the third one is some useful toolbox, either sensors or some visualization apps we're working on. Hopefully that will make much easier for you to, or for any runners, myself as well, to aware of the exposures on our daily lives, so we can exactly change or modify our behaviors. Back to this question: runners are fit, not air pollution targeted population. Are you agree with that? So leave the comments and let me know what you think about that. And we really wanted to hear about your voice, and we definitely need more research or evidence if we wanted to know how much impact of air pollutions on runners, on exercisers, on those who really like sports, like active exercise. What's the health impact? And then we can get improvements about air pollution. Beyond that, I would say this is quite nice program I found out last year. It's raised by Patagonia, kind of like a very good improvising companies. And then they have this activities calling Running Up for Air with the Patagonia. They just actually ask the people to running on mountains or elevation, any elevation runnings, and then they will donate. I think donate every dollar for every 1 meters, 1 kilometers or elevations sum up for the whole activity around the world. You can run everywhere. You can run just on the stairs. You can run on the mountains. Doesn't matter if you run only 5 stairs, is fine. Whatever, just join them, and then running for their this activity, they will just donate whatever they have for the clean air. So I think that's a good way. Maybe we could. I think runners who like to run and think about their efforts could make a better air quality for the world or for the everyone around us, the environment around us. That would be great. So I think that's another dimension or level why runner concerned about air pollution. And I want to end my talk with this plot, or it's actually one of my running trajectory in the past, no, the year before. It's actually the Chinese New Year of Tiger. I use sensors and also watches to try to do this running, which is pretty fun. Just run a tiger pattern alongside the London, and you can see that on the neck of the tiger, which is actually the King's Cross area. You see a high pollution, and also another high pollution area is around the city center area. So again, we can, with the tools, we can have a lot of interesting things. We can make the things not only helpful or for the community, for the world around us. We can also enjoy it. We can also have a lot of fun with it. So let us know what's your idea, and I really love to hear your voice, your thoughts on this topic. And definitely I'd like to look into in this area as well to see how I can contribute to this topic to runners. So this is my information. Happy to take any comments or questions. And thank you very much for the Bristol London community to invite me for this talk. I really appreciate it. I learned a lot through the process, and hopefully we can just get more done. Okay, thank you. I'll just end the talk here.